We started on Thursday by framing the general element drawing, and I believe that for everybody who followed through, we now have an idea of how to frame the general element drawing.
So, hi everyone, what's going on here?
Hello,
Oh,
is that young man with us?
what's going on here? What's going on here? What's going on here?
Hello, are we in the same meeting, Mr. Diwale Adragbe?
Yeah, we are in the same meeting. Yeah, yeah.
All right. So, what's your question, please?
The point is, what's going on right now? What's going on? We haven't seen any update yet.
You've not
What's
seen
going on?
you've not seen any updates in a meeting where you heard that a conversation is going on. You have to just be patient and catch what's going on.
Okay, 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 okay. Yeah, now.
The meeting has started already.
Oh, I'm sorry. I'm sorry about that. I'm sorry.
It's all right.
All right, sir.
Yes, thank you very much.
You're welcome.
So on Thursday, we were able to take ourselves through the general element drawing. Yesterday, we started with product structure, where we actually modeled and designed our structure. Today, we'll be picking up from that angle, and I'll be sharing my screen right now so that you all can see. In case you missed any session at all the videos have been made available on my YouTube channel, and I thought I shared the link yesterday so that everybody can easily get back there and see the video over and again as much as you want. All right, so can you see my screen?
Yes, sir.
All right, so this is our model. We have this already from all that we were able to do since Thursday, and we have designed this all correctly. All right, so today what we're going to be doing today is to see how we can bring the final outputs of this structure, of this design from product structure back to AutoCAD where we started. All right, so it's going to be very, very simple task. Product structure is quite different from Orion in that you don't go directly to AutoCAD from there, but rather you actually plot all your drawings on the product details. There is another package that comes with product structure. It's called product details. So you have to plot all that you have on product details before you go forward or further to AutoCAD. Right. So having done this, you want to check whether your designs, everything is okay. Checking through the columns designs, we know that we now see that all of them are passed. We have no issue with any one of them. Let's check the beam. The story beams, all has passed. We don't have issue. Alright, so there is one more thing I would like to show you before we take our time to export our drawing, and it's the slab design. How do we design the slab on product structure? Because yesterday we didn't do it. Alright, so the design is the next thing, then we export. Alright, before you can do the slab design, you need to create slab strips. There is something we call slab strips. When you get to the modeling tab, like you can see here, you find slab strip where my cursor is. Alright, so this slab strip, you're able to choose or make an analytical approach to your slab design, choosing the slab type and the end conditions as you can see now, and you pick which directions that applies to that slab in question. And with this slab strip, it helps the software detail and design your slab. Alright, so let's see how it applies practically. So once you are about to start this process, you click slab strip. You can see a box right on your right. You have different type of strips. We have analytical strip, we have FE strip, we have manual. The FE strip we use that in raft foundation. and the analytical strip is what we use in this case, this suspended floor slab. All right, so we'll use the analytical slab strip. Now we're going to pick direction. You can start with X direction or you may start with Y direction, whichever suits you. All right, but you have to be conscious of the condition of your slab while doing that. And if you check this, you find at start and also find at end. All right, so let's use the we are going by the X direction first. So the start for this panel and this panel, this region now, the end condition here is this. Look, I will have beam at the end of this. We don't have beam here. This is a continuous condition. This is a cantilever. You get that? The first one is a continuous setup between panels. The second one is the end condition, that is the continuous part of your slab panel. Then the third one is the cantilever. All right, and that's simple. All right, so to just go further concerning this panel that we are considering, just select the start as this condition and the end as this condition. What do you do now? You select somewhere outside that point, holding down your control panel to make it straight, your control key to make it straight. Then you come outside there. So it captures the two conditions. At the start, it captures that is a discontinuous end, and at the end, it captures also that is a discontinuous end. Then you can click there and drop it. So having dropped that, you see what we have. Automatically, there are reinforcements fixed, even though this reinforcement at this point had not been designed, as detailed that for you at that point. All right. So let's check for other panels, and that's the approach we're going to take all through. It's still consistent to say that this panel, the end condition here is discontinuous, and the end condition here is discontinuous. So I may take my slab strip for this panel all through this way. I'll still be correct. You see that now? I can take the same thing for this panel also. I'll still be correct. But when I get to this panel, I may want to use something different. The start condition remains the same, but the end condition is continuous because I want to stop my slab strip here, and there is continuity here. So at this place it's continuous, and at this place there is continuity. That's why I changed the end condition to that of continuous end. You see that? All right. So I feel on the slab strip for this panel, I'll go for the start as end, continuous, and I go for the end as discontinuous. All right, so we can just take it from here to go down here. See that now? Then for this also, we do the same. All good. All right, so we can now switch our directions to um y axis. I believe you guys are following.
Yes, yes,
Yes,
yes.
sir.
We are.
All right, thank you. So we can switch
Yes, sir.
the direction to y axis so that we can do that from there. Now let's check the start condition. Start and for this and this, they are both discontinuous. Start and end. But if we are going here also, that's correct. If we are going from this panel down to this panel, that's correct. But you discover that we have missed this panel. So you need to treat this panel alone. And this panel is an interior kind of panel. So the start will be this, while the end will be this. Click here and here for that. You see, we are done with this. What about this? the beginning here, if I'm starting from here, it will be interior. Then if I'm ending here, it will be end. So I have to start from here down to this place. For this, my start will be end, and this one will be end. So I have to use this. All right. And this also end this continuous both ways. Now you see that my slab strips have been completed, and you can already see your reinforcement there already. You can see your reinforcement there already. So let's design what we have detailed, or the slab strips that we have fixed. Let's now design it to see what fits it. Now you have to come to design. When you get to design, you find slab analysis and design. This is where we design this stuff. Slab analysis and design. So clicking that, you have different options. Design, do not modify existing steel, means don't touch the steel that you find in the detail. The second one is only reselect insufficient steel bar. That is, you you leave all my reinforcement as it is, but the ones that you feel it is insufficient, you change them. The third option is delete and reselect all steel bars. My slab streets will be still be intact, but I want you to select all the reinforcement again afresh, such that all of them will be the correct kind of reinforcement. So you may use whichever the option suits you, right? But I would like to use delete and reselect all steel bars, so to be sure that all my steel bars were selected after the design. All right, so I use design. So you wait for the result and see how it comes out. And the beauty of the slab design is that after the design process, it comes with a calculation sheet, and from the calculation sheet, you can check through to see if all your reinforcement had passed or we have any query along the line. All right, so this is the calculation sheet for the slab strip right now, and you discover that um, all the panels individually. This is the slab panel now, for example. It had done deflection. Normally, most of us have been to the classroom. We have learned design of structures. That should be CVE or CEC, whatever it is, 30, 8, and 10, whatever it is, for those in the polytechnic. All right. So there are different things calculated for you here. The area of steel have been calculated for you. The deflection check has been done for you, right? And even the support enforcement have been calculated. So you just need to check through to see what are the spaces, the the deflection, did it pass? You see now this one is telling us that it's sufficient deflection. You see that? All right. The support moments and the area of steel all fixed. So we have to just check through. Do we have any query? Do we have any failed panel? Do we have anything we need to pay attention to? And that's very important. Very, very. All right. So you see also now sufficient. My deflection is okay, and everything is fine. All right. So if you want to print this, because by the time you are compiling your calculation sheet, you have to put this as one of the documents that you will need in that regard. So you can convert to PDF here by clicking this. Automatically, you are ready to convert to PDF. You put the name as you want. For example, Slab, then you save. That's all. You can save. So by the time you are printing, you can print this as it is. You see now. All right. So other ones can also come like this. Okay. So that's how you do that for slab, for the calculation sheet. Let me just show you how to do those calculation sheets for your for respective elements, so that we'll just do the exports at once and we'll be done for the class. All right. We'll close this slab design. Since our slab reinforcements are correct now, everything is good. All right. So for the beam, we did that yesterday. We did the design yesterday, so all had passed. But how about the design calculation sheet? So the thing is, you can't print all the calculation sheet. That would be like a textbook. It would be like a go see go. If you know that kind of, it will be very very bulky. If you print all that the software done for you, what we do is to pick typical elements that can represent major or critical elements as per loading or span or condition around that place. So we pick those critical elements and we show the calculation how they fit into everything that we've done. Right. Okay, so with this now, let's pick few. So because all was marked before. So let's just pick few. So I have to remove print marks, then I'll pick few of them. So let's pick few of them, about three or two that will print. So I pick this for a is a continuous span for a continuous beam, right? So I pick that. Then this is a simply supported beam. I pick that too, and I pick a two span beam. All right. So let me pick that. Now you can use this method, or in fact the most accurate method is to go back to your plan and check the beams that are more critical or that can represent the critical points within your framework. And I would pick according to observation. If you look through your work, I might want to pick beam 3A, beam 3A, or beam 2A. Any one of the two. I'll pick this simple supported beam, beam B2. This beam B2, I'll pick that because it tends to be heavier on that part. And probably I'll now pick this continuous beam D that goes on through. Beam D, beam B2, and beam A. So that's what I'll pick. So there is a way we filter to show that of the first floor, only the first floor. So on the first floor, all I want to do is to print beam B, beam 3A, and beam D. If I'm not mistaken now, beam 2. Where's beam 2 now? Yes, this. So I can print. Now to print, you see this design report that you have here. Just click design report. You see it gives you about four options. Print beam loads. That is, your calculation sheet will contain beam loads, shear force diagram, bending moment diagrams, and if you want it to split table, it gives you the insight that it's going to have more pages, but it will be faster. But we don't have any reason to be rushing. So why do I need to have more pages when I can have the required details in a very reasonable number of pages? So with this now, let's print. Okay. Now you can see we have the shear force and bending moment diagram and the loading diagrams. All right. Um, all that you need as touching this design. If you had gone manual on the design, you would have achieved or obtained the same result. Somebody asked a question yesterday and said he has observed that product structure over reinforced or something like that. That's a common notion, but I'll tell you that that's not really true in all cases. Even though you want to say it's over reinforced, using the word over reinforced might not be accurate because what it does at some point it has slightly higher values than what your manual or other softwares might give you. because of the design approach or the program, the way the program are configured, and I explained yesterday. For example, you discover that these are this, for example, here represent the shear force, and this represent the bending moment. The third diagram you're seeing represent the bending moment. And in class, if you are working with the first principle manually, you discover that the moment at this beginning point, this beginning is supposed to start at 0 point, yes or no, and end at 0 point if it's not a cantilever or whatever it is, or fixed support. Is that true, engineers? All right,
Yes.
that's true. So, but you discover that there are values at that point, meaning in the configuration of this program, there have been an allowance at that point for moment. That means there is fixity at those ends. So it will relieve the moment at the midspan, then increase at the support. So whoever now comes to the support will say that the reinforcement at the support is now more. But he had not observed that of the midspan, making it realize that that which is supposed to have affected largely the midspan had been relieved and fixed at the support. So it's just a matter of design approach, and that's why it's important to understand manual calculations so that you not just be lost in the way of software. Something that can't talk would not be overruling your life as a structural designer. And that's why in my private design class, what I do is that we take manual courses. In fact, we started months ago. We have not opened product structure in our class to today. We have not opened any structural software till today. We have been doing manual calculations all through, including these designs that we just did on product structure. My people did with the hand. They calculated everything with hand. They are still on it now. All right, so that they can know the foundation of this thing. They can become a correct engineer, not a software. All right, they can know how the software came about a thing, why this one is this, how is this, and what are the alternatives. It makes you better that way. That's my philosophy. It makes you better. All right. So I can go months on manual calculations. I'm very good at that. All right. And that makes a difference. Okay, so this is how to get it. This is how to get it. So if you want to print this one, you can just print PDF. You can put the name in. You can see that the slab we printed the other time is already there. We have, that's it. This is simply supported. Now let's just make a very simple example of what I'm saying. According to our manual design, our first principle formula, it would if you want to obtain the maximum moment of a simply supported beam, we know we use WL square over 8. But if you use WL square over 8 here, your value will be a little bit lesser than or greater than what you have here. Can we try something else? 35.139. That's the maximum load on that. If you have your calculator, let's just try something out. Let's try something. 35.139 multiplied by the span here should be 4.58 square divided by 8. The value there is 92.14. So that's the value for the moment at the midspan. But what Proda has there is 62.299 as the moment at that midspan. Somebody would not say it's wrong. I would tell the person it's not wrong because that WS cover 8 was adopted when the moment at the end were supposed to be 0. But in this case, product structure is considering WL square over 12 at the end, so that there will be a relief on the midspan. So your support reinforcement tends to be higher than that of the midspan. That's the approach. So if you do not know what goes underneath, if you are not a good designer, you might just be fighting what is not and be claiming what is not. You see that? So and that's why it's important for you to know many things aside from software. Alright, so that's beams. We've done that for beams. Can we check columns now? Still here we find columns. All had been designed yesterday. You can just print a number of them.
Yeah.
Alright, so I can just print let's print few number of them. Remove
That's right, yeah.
members. I can just print one column 4 and one column 5. One column 4, um how do we do it? Let me just print one column 12 and two column 12. Let me print a circular column, one column 25, one column 24, and two column 24, and probably one short column. So when you are done with that, you can use the design report here. Include all loading combinations in the report. Yes. Include interaction diagrams in the report. Yes. Display all combinations in the interaction diagram. Yes. Include this. Then you press OK. Let's see what we have. I believe people are following. So
Yeah,
this
yeah,
is
I'm catching up. Catching.
yes, right.
Yes, yes.
So this is how to generate the calculation sheet for columns. See that? So it gives you the shear force values. It gives you the ratio L over B and that of the additional moment or the reduced moment. Alright, we have reinforcement, the area of steel required and area of steel supplied. Okay, so all through that you have all. To print this is a circular column. And we know that what's the minimum number of reinforcement for the circular column? Anybody?
What is 20?
Minimum number of reinforcement for circular column.
I think it's not 12.
No, that's not true. Minimum number of reinforcement circular column. Anybody? It's not 12. Having 12 reinforcement in a column is a lot.
Okay, wait.
Alright. Look at this section and tell me the answer.
6. Six, six, six.
6. That's the minimum number of reinforcement in a circular column. What about a square or rectangular column?
Mr. Joshua, I wanted to ask a question. I've been raising up my hand for a while now.
Oh, sorry. I'm sharing my screen. I can't really see Google Meet.
Or is it that the question section will come in later?
If your question will not be delayed too much, you can just come up with anything.
Okay, no problem now. Go on with the presentation. Maybe I'll ask the question anytime soon.
All right. So I had that. What about for square or rectangular column? What's going to be minimum number of reinforcement?
I think for
Four.
a square and rectangular, we have four as minimum.
Four as minimum. That's number. Now, but for percentage for columns, what's the percentage or minimum area of steel? These are simple things engineers must take so dearly to avoid issues. Percentage, minimum percentage for the area of steel in columns. All right, that's 0.4% BH. 0.4% BH. All right. What about the minimum percentage for area of steel in slab? Do I have any of my private students here? Let me check now because if they are here,
0.13 or 0.24 percentage.
all right, 0.13 or 0.24. Can you give me a distinction? Where's the difference coming from?
One is for high yield and one is for might steel.
What's the IE? Which one is the IE?
I can't really differentiate now, but I know it's 0.13 and 0.24.
Oh, that's for you to even think of that. That's very good. 0.13 is for IE. 0.24 is for mild steel. All right. Thank you very much. I appreciate it. All right. So, who spoke just now? Can I have your name, please?
Daniel Joseph.
Okay. Thank you. All right. So, to print this out, I just showed to you. Just showed to you. So, you can close that after you're done. Okay. Let's just, if you want to print, you can just pick PDF here, call up, and save. All right. So, that's how to save that. Then you can close. What other components? Let's check for our foundation. Our foundation. That's on the row. Right. So you can come to here, pie cap and pad basis. All right. Just come here, select few that you feel you want to show. All right. I want to print this one too. All right. So clicking that already, I can come here, just right click. You see that I right click on that place and it says show pad footing report. Show pad footing report. So clicking that now, expect report. Now this is it. This is the plan that's giving you the size 1 meter by 1 meter and the depth of your foot 250. Now there is a relationship between the depth of your footing and okay, let me just ask a question so that I would be straightforward. There's an effect that your column tends to have on the base, on the pad base, and that effect wants to tear it apart, wants to tear it along a plane, wants to cut it along a plane. What's that effect?
Come again later.
I said there is an effect your column would
It's
most
punching,
likely
punching, punching.
punching. Exactly, that's the word. Punching chair. So you discover that that's one of the important things you design for, particularly in your foundation base. Punching, because there's an effect of punching. The same thing we design for in flat slab. Whenever you have a point effect on your concrete element, it tends to have a punching effect. All right. So what are the things we would most likely prefer as solutions to a punching effect, either to prevent it or to stop it, the action? What are those things you do? You can see my calculation for punching check here. So what are those things?
Take 1.5 each and you design for share, punching share.
So that's calculation. You are checking for punch. That's punching check. That's 1.5D away from the face of the column. All right, but that's on calculation. I'm speaking about what are those things measures that you adopt as an engineer to sort punching effect.
Okay, thank you so much. I wasn't about to ask about the punching check, but thank you so much. You've already explained it.
Okay, that was your initial question.
Oh, no, no, that was not my initial question. My
Huh?
initial question was about the deflection you talked about.
Okay. So let's sort this one. We'll come back to
Yes, yes. I will still ask that question because I still want to know.
you. All right. Okay, so who's answering my question? What's the way forward? What does the engineer put up as a measure to mitigate against the effect of punching? All right, let me just tell you. Now there are about two primary measures. The first is to deepen the section receiving point load. All right, so the depth of your section, if it's the slab section or your base, the thicker it goes, the safer it is against punching. All right, so for example, in flat slab, you see that at the region of your column points, they create stuff like column heads. So the ideology is to make those points thick enough to prevent the punching through. You see that now. So deepening the section at that point, deepening the sections of your concrete element would prevent could prevent that. All right, and also making the thickness around the column. It could be just the thickness around the column, making it thicker. The section could help against that. So that's good. All right, so let's just proceed. If you want to print this, I already showed to you PDF, hard base, call it whatever you want. See, then you have it. Close it now. Now let's move to product detail. How to export all that we have for presentation. Get to drawings and reports. From here you find the Prota detail. So you can load your Prota detail. You want to save, of course, yes. And you wait for your product detail to load. Alright, so that's my product detail. So all of these I'm taking you guys through. Even beyond this, I have all of them on my channel. There is practically no product structures problem or solution or tutorial that you're looking for that you won't find on my channel. There's virtually none. Maybe a little. I don't. There's virtually none. All right, so you can just start by creating a new drawing. Start by creating a new drawing. So we want to begin to create all of our drawings. Now on the left hand side of your template, you find this manager. You see detailed drawing manager. From there we can export our drawings, and from there we can make new drawings and make new drawings. Alright, so let's begin. Let's draw our form plans. Our form plans are the same thing as general arrangements. They are the arrangement of the columns, beams, and everything, the details that were used in the design. Alright, so let's draw that of foundation. Right click on it and draw. Now you have many options here. You really don't have any problems with that. You don't really have problems with that. Except for the fact that I don't want to see my reinforcement in the G. I don't want to see reinforcement first. Pardon me. So we can draw now. Select anywhere on your template. Then you have it. You see that these are our columns, the column points as we have them on product structure. So let's have the first floor general arrangement. Don't forget the form plans are also general arrangement drawing, just the name that differ when we come there. You draw here again, selecting the point. See now, and you can move. You can do anything you want to do by lighting. This is move here. Click that, then move. You can do that. Now select for the roof also. You can do the same. Let's draw that and we drop. You want to move, you can move. You want to copy, you can copy. Please copy here and all of that. So let's draw the column application plans. These column application plans will show for you. You can show the link details, you can show the reinforcement details for your for respective floors. So let's draw that. So you see, it shows for you the reinforcements that you have. You may choose to show the links detail, you may choose not to show in the settings that I showed you. Alright, so that's on this. Roof draw. I can hide link details if I don't want to show it. Draw. See now, shows the reinforcement details, shows the number 4y16, 6y16. You see that. That's for column elevation. What of column elevations? Now, there, there are a lot of ways to show your column elevation. You can draw it floor by floor, but meaning it won't connect the, for example, if a column starts from the ground floor and goes to the roof, if you draw it one after another like this, it won't draw the full length of that column. It will draw it from ground floor to first floor, and you will need to come to the set storage to draw the second one and to draw them separately. But the right thing is to draw the two of them as one. Not that the right thing, but the more appealing way is to draw the whole length together. So what we do is right click from here and draw column elevation. So we'll find in a dialog box, look at this box now. There are it has selected all the columns that I want to draw, but there is an option. The option says generate column through storage. That's what we need. It's going to connect all the columns together. If the column is a full length across different stories, we're going to join them, merge them together, and help us with it. Draw similar columns together, yes. Write column label below sheet, yes. So can we draw now? Let's fix. Now, you see, all my colors are here.
So sorry, please. What time will the class end? So I will join. I will rejoin the class like in 15 minutes time. I don't know. What time will the class end, please?
Probably in the next um 10-15 minutes, as you said, because what I'm left to do is to export these drawings and take questions.
Okay, no problem. Let me just hang on now. But I'm on my way going back home, sha. But let me hang on.
All right, great. So we have this for the columns. Let's move to story beams. You can draw beam elevations. You can also insert to sheet if you want, and you can also select different sizes of paper as you want. So that you can draw. All right, you see now. Look at my beam elevation. Look at the section. So that's how to generate that beams. Can we check with part footing? Can select as much as you want, or you just draw everything. Look at the part details now. It's giving us combined top and bottom reinforcement. Top and bottom reinforcement. So that's exactly how to draw all your elements. So how do we pick them from here and take them back to AutoCAD? Now, you see this? Export the WG or DXL. Then you can click export. So we're exporting as drawing one from this job. Export. So it's loading, as you can see. Loading now. Done. I have an AutoCAD drawing of what I just did here. My AutoCAD is loading. So my AutoCAD is still loading. Let's wait to see what we have. So we have all these drawings on AutoCAD. So now left to you to fix for presentation, edit the text as you want, and fix into your own customized template. Probably you have a company or firm that has its own customized templates. Just pick these drawings, fix them into those templates, and all right. So that's just a template like this one I'm saying. So some people have this kind of template, this kind of sheets customized already for them. So you just fix all those drawings. This is perfect enough. These beams are perfect enough. All right. But for others, you can find your template and fix those things inside, or you do it from Buddha structures. I've done this before. All right. So that's cool. Um, the I have a product structure course, a full course that's to be launched this month. All right, it has gotten to about 80%. All right, and it covers everything plus, my channel that is there, everything it covers. So it'll be out for sale in matter of weeks, and I believe to communicate to everybody as soon as at least for every 1 year to be at a very very low or affordable price, not low, affordable price. So of which after some weeks it goes back. All right. So at this point, I believe you've been able to start a design project and export your solutions. So these exactly are the things you put together to form your document that you send to site for execution. All right. So let's begin to take questions so that we're able to come to a very good conclusion.
Please, I'm going to know when your tutorial will be out. Your full tutorial on product structure.
Like how are you going to know? All right. Probably I'm going to send. I believe I have emails of you guys. I believe I do. I should send an update via email and also through my community post and every of my other platforms. So
All right,
that's
sir.
just what I'll be on.
Okay, sir. I was not able to register, so I'm sure you don't have my email because I'm having YouTube issue because my phone is having YouTube issue, so I couldn't subscribe to your page and upload the document as required.
All
So
right.
you don't have my email.
Can you do
That will
something
not
for
be.
me? I have a video
Okay,
on
sir.
YouTube channel for day two of this program. Can you comment so that I'll be able to attend to it? I won't forget.
Okay, I will do that with my system because I can't access YouTube with my phone right now. I'm having some issues.
Okay, that's the best way for me to remember, so I don't want to forget.
Okay, I will do that later this night when I get back to my system.
All right, great. Can we have questions now?
Yes. Please, how much is the training that you see is coming up?
For now, the cost has not been fixed, but trust me, it's going to be very affordable, at least for us. Very affordable. In fact, I'm thinking for the first week. I'm thinking I did not say probably. Nigerian naira is going to be about 5,000 naira for the first week. I'm thinking I don't because that money is way too cheap to get, but I'm thinking. So probably after some weeks, it goes back to normal fitting price. But just for Nicesa, can still go by an affordable price.
Okay, so the class you're talking about, is
Please,
it the
also tell us the existing requirement.
What do you say?
I said the class that you're talking about, is it the master class where we can also learn manual design?
No, the product structure course is a course on its own meanwhile. But I have a private design class. There are two different things now. I have a private design class. The product structure is a course that you buy the course and you use the materials to master product structure.
Okay, so how can one join the design class?
You have to reach out to me personally so that we make interactions.
Okay.
And I think you have
Okay.
my details.
Yes, yes.
Yes. So we need questions.